students, welcome once again. Now in this section we have to solve for the real values of x, right? We have 2x plus 2x divided by the square root of x squared minus 1 equal to 35 divided by 6, and we are to find the possible values of x, right? Okay, so in this case, if you look at the denominator over here, it looks like a trig function, right? So what we are going to do is that we are going to set the whole of this right here, let's say x here, being equal to sec theta. Now why sec? Now the function sec is outside -1, right? They take values, but these values should be outside of -1, right? Now when we square this side, so we have the solution. Now when we square both sides, we have sec squared what? Theta, right? And from here, when we subtract 1 from each of the side, we have x squared minus 1, and we have sec squared theta minus 1 here, right? So we realize that this is just this over here is just that, right? Okay, and this sec squared theta minus 1 is just tan squared theta, right? It's just tan squared theta. Now good. Now if you look at the x squared minus 1 here, this value should be greater than 0 for the function to be defined, right? So if it's greater than 0, then we have x squared here, we have 1 here, squaring this side, and then squaring this side, we have x here being greater than 1, so which means that the value of x should be, values greater than 1 for the trig functions over here. So if that is the case, then which means that tan squared is basically equal to x squared minus 1, right? So this is just equal to that. Then which means that for tan theta here will be equal to the square root of x squared minus 1 in this case. So which means that we can replace tan theta here into the equation over here, and therefore we said that x here should be what? Sec theta, right? So let's replace that now. So we have 2 sec theta, right, plus 2 sec theta being divided by just tan theta, right, being equal to 35 divided by 6, right? Now let's define theta over here. Now theta, right, should be values, it should take values at the range of 0, which is less than just theta, which is also less than half over 2, right? So pi over 2, right? So these are the values of theta. Now from here we have that. So let's further simplify this. Now we all know that sec theta is just 1 over cos theta, right? So if sec theta is equal to 1 over cos theta, and also tan theta is just sin theta divided by cos theta. So if that is the case, we are going to substitute this into the general formula here. So we have 2 over cos theta here, right? Then plus 1 here. Remember it is so we have 2 being divided by cos theta, and this whole thing here is divided by sin theta, then cos theta, right? And this is basically equal to 35 being divided by 6, right? Now cos theta gets rid of cos theta. What are we left? We are left with 2 cos theta here, right, plus 2 sin theta here, right, being equal to 35 divided by 6, right? Now from here let's further expand this. So we have cos theta, sin theta here. So over here we just have 2 sin theta plus 2 cos theta being equal to 35 over 6. So we can just substitute 2 out, and we have sin theta here plus cos theta here being equal to 35 over 6 here. Remember, divided by cos theta, then sin theta, right? Now from trig we know that sin square theta, right, plus cos squared theta is equal to 1, right? So if sine squared theta and cos squared theta is equal to 1, then therefore we can but even before that, before this trig function over here, let's send this to the other side. So we have sine theta plus cos theta here in the brackets, then 35 6 here plus 6 here, then we have cos theta sine theta. Remember, we have the sum and also the product, right? So let's set this to a variable. So we are setting this to a variable, let's say a, right? So if a is equal to sine theta plus cos theta, then which means that when we square a, right, when we square a, so let's square a. Now when we square a, we are going to get sine theta here plus cos theta here all square, right? That's what we are going to get. So let's simplify this. We are just going to get sine squared theta, right, plus 2 of cos theta sine theta. Then also we have cos squared theta, right? Now we have so since we wrote this over here, let's put them together here. So we have sine theta plus cos theta here plus 2 cos theta, then sine theta, right? Now sine squared theta plus cos squared theta here is equal to 1. So if that is the case, then we have this to be 1 here, right, plus 2 cos theta, then also sine theta, right? Okay, so what we'll do next is to make cos theta and sine theta the subject, right? So we have cos theta sine theta here will just be equal to a squared minus 1 here, then being divided by 2. That will be for so basically let's call this equation over here. Now remember we had this equation here, so let's call this equation here equation 1, and let's call this equation 2, right? Okay, so what we are going to do is so if, but then also remember that we said sine theta plus cos theta should be a, right? So if a equal to sine theta plus cos theta here, so let's call this one just equation 3. Now what we are going to do, we are going to substitute this, right, into the equation 1. So we just put equation 2 and 3 into equation 1, right? We just put this into equation 1, and equation 1 was just 2 here, then multiplied by sine theta cos theta. Sine theta cos theta is just a in this case, then being equal to 35 here divided by 6, then multiplied by the product of cos theta and sine theta. So the product here, we add that one to be a squared minus 1 here being divided by 2, right? So let's do this. We have 2a being equal to, now what do we have here? We have 35 here divided by 12 a squared, then minus 35 here divided by 12 here, right? So what we're going to do next is to multiply both sides by 12, multiply each side by 12, then this place will be 24 being equal to 35 a squared minus 35 here. So let's write this for, so that will be a squared here minus 24a, then minus 35a being equal to 0. Now we have a quadratic equation, and we are going to solve the quadratic equation here. So let's do this. So in solving a quadratic equation over here, we realize that the coefficient of a is 35, and the a here is just 24, then 35 over here. Now we can apply the quadratic formula, but then also let's see one trick over here. So I'm going to use a trick in solving this. Now if you look at 35 here, right, we also have 35 here as a constant, right? Now what are the factors of 35? So we can have 7 and then 4, 7 and 5, right? So we can have 7 and also 5 as the factors, and here also we can have 7 and also 5 as the factors, right? Now how do I get this? So basically when you look at remember it is a, so we can have a. Now when we multiply them, right, 5 multiplied by 7 is just 35, and then with their variables a will be a squared. Now 7 multiplied by 5 here is 35, but it is not negative, right? It is negative here, so which means that one of these has to be negative. But then also we must consider the 24 over here. So 24 is just multiplying. Now if you multiply 5 multiplied by that and that, now 5 multiplied by 5a multiplied by 5 here is just 25a here. Then we have 7a multiplied by that is just 49, right? Now when we subtract them, right, we are just going to get negative 24a, right? So we have this, so which means that 7 here should be negative, right? So if 7 is just negative, which means that our formula is just going to be just the 5a here multiplied by 5a. So we have 5a and then also 7 here, and we add 7a and that, so we have 7a then plus that, and this will be equal to 0. When we expand this, we should get that, right? So this is a simple trick to use. All right, so let's take this equal to that. So 5a minus 7 equal to 0, then 5a will be equal to 7. A here is basically 7 over 5, and then also 7a plus 5 being equal to 0, and therefore we have 7a here being equal to negative 5. A here is just negative 5 divided by 7, right? So these are the values of a that we had. Now a here is negative, right? So it will be it can't be possible for that, because a will take positive values, right? So we are just considering a here being equal to 7 over 5. Okay, so from here, remember we said that a equal to cos theta plus sin theta, so which means that 7 over 5 here is just equal to cos theta here plus what, sin theta, right? And then also we said that a squared minus 1 here divided by, that is for equation 2 and equation 3, right? This is equation 3 that we did over here, and this is so we have cos theta plus sin theta. This is just the equation 3, right? We are just substituting the values of a into that. So from here we're just going to get from here we just have now what is a is 7 over 5, so 7 over 5 squared is just going to give us 49 being divided by 25 here minus 1 being divided by 2 equal to sin theta plus cos theta, right? Okay, now from here we are going to get sin theta, remember is the product, sorry, so they are multiplying, so we have the whole of, so we have this to be 12 here divided by 25 here being equal to this sin theta then cos theta. So this will be, so let's call this one just a, and we add this, let's call this one b, right? Okay, now remember we have their sum, so this is just a sum, right? And this is just what, the product. Now what does this tells us? It tells us about what, the quadratic root, right? So for the quadratic root, the general equation is given by x squared minus the sum of the roots, right, the alpha and the beta roots, the sum of the roots x here, and also their product, right? the product here being equal to 0. So we are going to use the formula to write out the equation here. So if that is the case, we have s squared here minus, what is the sum, right? So the sum, we had the sum to be 7 over 5 here, right? We have 7 over 5 here, x, and also the product, we have the product to be just 12 over 25 here being equal to 0, right? Okay, so all right, so there's what we have. Now we are going to apply the same trick as we applied in the previous one. So over here we have 12 being divided by 25, right? What are the factors of 12? So we have 3 and also 4, right? And also, let's say divided by 5, it makes sense, right? So now when we multiply 3 multiplied by 4 will just give us 12, but 3 plus 4 here will just give us positive 7, but it's negative. So let's negative both sides. When we negative both sides, we have negative 3 divided by negative 3 divided by 5 multiplied by negative 4 divided by 5 will just give us positive 12 over 5, and when we add them we should get negative 7 over 5. So we are just going to get negative x here minus 3 over 5 here, and then also we have x here minus 4 over 5 here being equal to 0, right? Okay, so if that is the case, then x minus 3, yeah, x will basically be positive, and over here x here will just be 4 over 5, right? So these are the values of x. Now we have this, we are still not done. Now what we are going to do next is, all right, so if that is the case, now we said that x is equal to sec x from the beginning, right? So basically x here, sec s is just 1 over cos x, right? Okay, so if that is the case, so sec theta, then cos theta, then if that is the case, which means that our cos theta here will just be 1 over x, right? Now so our now why am I taking cos and not taking sine? I'm taking cos because we assume that x here is equal to sec theta, right? So if x is equal to sec theta, then sec is just 1 over cos in terms of cos, so we take cos. So cos theta here, so we have cos theta here being equal to 1 over what? X, right? Now for x being equal to 3 over 5, then which means that cos theta here will be 1 over 3 over 5, which is just equal to 5 over 3. And for s being equal to 4 over 5, then which means that cos theta here, right, cos theta here will basically be 1 over 4 over 5, which is just equal to 5 over 4, right? Which is just equal to 5 over 4. So therefore, right, so basically our s values will be 5 over 3 and then also 5 over 4. Now when you substitute this into the general formula, then so the general formula was 2x here plus 2x here, then we have s squared minus 1 being equal to 35 divided by 6. When you substitute the values of x into this equation over here, then you should get your 35 over 6. So thank you very much for joining me in this section. I hope this section was helpful, and if you are new here, please like, subscribe, and also hit the notification bell, and also leave a comment. Thank you very much, and I'll see you in another section.